Hello and welcome. In this video, I'm going to showcase the newly released CashScript WalletConnect integration. This will make it much easier to integrate WalletConnect into your CashScript Dapp. This was released in the version 0.11.2 and 0.11.1 releases. Before I delve into the specifics, I just want to highlight that we also released 3 weeks ago the long-awaited version 0.11.0 new major release. This was in beta for quite a while and adds support for the new BCH 2025 network upgrade. I made a dedicated video about all these new changes when it was still in beta, so be sure to check that out if you want more information. But for now, let's dive into the WalletConnect integration. So we added a generate WalletConnect transaction object method to the transaction builder to generate a WalletConnect transaction object that can be used to sign a transaction with a WalletConnect client. So the process that we will be using is you have a transaction builder, you call the generate WalletConnect transaction object, which returns this WalletConnect transaction object that you can pass to the client. And then secondly, we added placeholders, a placeholder signature, a placeholder public key, a placeholder pay to public key hash unlocker. So these are all helper functions which were added to the SDK for WalletConnect usage. And why do we have all these helper functions? Well, it's because when your Dapp communicates to a wallet, your Dapp constructs the transaction, but of course it cannot know the signature to sign the inputs and to sign the whole transaction. So it uses placeholders and passes the transaction with the placeholders to the wallet, and the wallet will detect these placeholders, and when the user confirms, it will actually sign the transaction and so swap out any placeholders, for example, for the signature or for the public key, and swap this out with real valid wallet information, so with a valid signature or with a valid public key. So that's why you need to use placeholders when using WalletConnect. And we'll now take a look at the full guide for WalletConnect of how to integrate it into your Dapp. So this is the CashScript documentation for WalletConnect. You can read the full specification here, as well as extra information on the research forum, but we'll just stick with whatever is written in these in this CashScript documentation. So most relevant for smart contract usage is the BCH WalletConnect sign transaction interface. This is a most generic interface to propose a Bitcoin Cash transaction to a wallet, which constructs it and signs it on behalf of the wallet user. So you can see here, this would be the sign transaction interface, where you pass in a WalletConnect transaction object, and as a promise, get back either a signed transaction object, which is in case of success, or you get back undefined in case of, for example, when the user rejects the transaction or when this signed transaction fails. We'll also, we'll take a look at this specific interface for the WalletConnect transaction object, and you can see that over here. So the WalletConnect transaction object has the full transaction, of course. Remember, this is with the placeholders. It also has all the source output information. Then it has a broadcast, so as true or false, you can ask the wallet to broadcast or to not to broadcast the transaction, and a user prompt, just a message directly to the user when signing this transaction. Here you can find more information, but we'll mainly want to focus on this return type. So the signed transaction object just has two properties, two strings, the fully signed transaction, which will be hexadecimals, and the signed transaction hash, so the hash of the transaction which just got broadcast also as a hexadecimal. To use the BCH WalletConnect signed transaction API, we need to pass a WalletConnect transaction object. The CashScript transaction builder has a generate WalletConnect transaction object method for creating this object. Below, we'll show two examples. The first using spending a user input, and in the second example, spending from a user contract with placeholders for user public key and user signature. So let's take a look. There's also a link to the full source code. So this comes from the Hodl Vault Dapp repository. From CashScript, we import the transaction builder and the placeholder pay to public key hash unlocker. And then in this proposed WalletConnect transaction, we start with the user address. This is the user address you already get when you connect to the wallet. When you establish a connection, then the wallet provides the address. So you normally have the user address in this context. And then we instantiate the placeholder unlocker, which uses this new function, placeholder pay to public key hash unlocker, and we pass it the user address. Then we do the transaction building, which is like usual. We instantiate the transaction builder, we add inputs, add outputs, and here we also add an op return output. Special in this case is that when we add the inputs, we see the user input UTXOs get added. So we add multiple inputs at once, but we cannot sign these inputs, right? Because we don't have the private key. These are user inputs. So we use the placeholder unlocker that we just defined here. We pass it in the transaction builder. And then once we are done constructing our transaction with inputs and outputs, we do here generate WalletConnect transaction object. This takes two optional arguments. We can add a broadcast property, which we set to true, so the wallet will broadcast this transaction after signing it. And to the user, as a user prompt, we say create HODL contract. So high level, what we are doing is we are spending BCH from the user, and we are sending this to this contract output. So we are creating a new HODL contract. And once we have this WalletConnect transaction object, we await it, and we just say await sign WalletConnect transaction with this WalletConnect transaction object. And remember, this sign result will either be undefined in case of failure, or in case of success will contain the WalletConnect transaction result. I will delve into this function a bit later to see how it works under the hood. The second example is spending from a user contract. So instead of the placeholder unlocker we used before, this is used to spend from user inputs. Now we will spend from a contract UTXOs. So this works a little different. But first of all, we import the dependencies, we import the transaction builder, and now we'll also use the placeholder signature and placeholder public key helper functions. Here we do the transaction building, and as we just saw, in the case of the inputs, we use contract UTXOs. And these contract UTXOs are HODL contracts, as you can see in the source code. So we would use HODL contract.unlock.spend to create an unlocker, and this unlocker needs user information. So only the user can call this spending function. But we don't have the user information. We cannot generate a signature for the user. So of course we use the placeholders. First we use the placeholder for the public key, because we don't have this, we only have the user address. So we use a placeholder, and the same we use a placeholder for the signature. And it matters that these are two different functions, because these are different placeholders, of course. So the wallet knows that it has to fill in here the real wallet public key and here the real wallet signature. And then the same, we generate a WalletConnect transaction object and broadcast true. And here we set as user prompt reclaim HODL value. And again, here we use sign WalletConnect transaction. So here here at the end, we will go into that now in more detail, what actually happens when we pass in this WalletConnect transaction object. How does it reach the wallet? Well, we need a bit of a helper function. And as you can see, this helper function is an async function called sign WalletConnect transaction object, which takes in the WalletConnect transaction object generated with the CashScript helper and returns the sign transaction object or undefined. So this function is the very same interface that we saw at the top, this sign transaction interface. So I hope this is starting to make sense now. What we need as helper functions to implement this is we need a new dependency. From the WalletConnect library, or from the WalletConnect repo, we need the sign client npm package, which we will import, and we also need stringify, so the stringify function from libauth. What we do then in our function is we try this just and catch any errors should anything unexpected happen, and then we return undefined explicitly So we cannot have any crashes in this helper function. Then you need to have this sign client that we import. You need to have it initialized. This is not shown in this example because it will depend on whether you are using React, whether you are using something like Redux, or whether you are using Vue, or whether you are using Svelte. So this implementation of how you initialize the sign client will be a bit specific on whatever front-end framework you are using. But then once you have instantiated it, you can await the sign client, call .request, and these are the parameters that are specific to BCH. So BCH will have a specific connected chain, then the user will have a specific user session, and what we want the user wallet to do is to sign a transaction. So this method is called BCH sign transaction, and as parameters we then pass in our WalletConnect transaction object. And why do we stringify it first? Well, this WalletConnect transaction object, it has begins and uint8 arrays, which you cannot transmit over the network as JSON. So we first stringify it. So this object becomes, the stringify function will encode any begins and uint8 arrays. And then we parse it again with json.parse. So we now have a full JSON object, which can easily be communicated to the wallet. So yeah, these parameters will all be communicated to the sign client, and this wallet will then get this request for BCH sign transaction with these specific parameters. So that's how it works. You need one helper function with a specific WalletConnect library, and then only you need to use the placeholders exported by CashScript, as well as the new transaction builder.generate WalletConnect transaction object with 2 optional arguments. So that's it. Really not too complex. It simplifies a lot of code behind this generate WalletConnect transaction object, which would easily have taken 100 lines of code to implement yourself, simply because this source outputs is actually quite a complex object under the hood. So CashScript now takes care of this, and this greatly simplifies the implementation. So I recommend taking a look at this guide, at this WalletConnect guide, and trying it out for yourself. Thank you for watching this video. Hope to see you in the next one. Bye bye.